to show you a demo of a cloud-native platform. This demo is part of a blog, which will be linked in a video description, where you can read more about the context, theory, and how these things work. So I will start by being a developer. As a developer, I care about my app. I want to develop features and not care about much else that I don't have to. My infrastructure knowledge ends on a Docker file. It's a relatively simple Docker file. Maybe someone from platform team helped me build it, but that's about it. I don't know much about Kubernetes or infrastructure or clouds. I know that my app talks to an Azure storage account and it retrieves files and shows the content on the web. I want to test those things. So, as a platform engineer, on the other hand, I actually want to make sure that my developers don't need to know all the context, all the unnecessary context, but still the infrastructure and everything that needs to happen happens behind the scenes. So in the blog, you will read that one of the tenets of designing a platform is having some form of portal. Portal is an interface between developers and platform engineers, something that makes it easy and intuitive for developers to choose the right thing to do. So it's time for me to test new features of my app, and I want to create it. So in port, I am clicking create. You can see here I can provide a connection string, an image, and a port. So just a minimum number of details that I need to provide. When we click execute, what's happening behind the scenes is port is reaching out to GitHub, to the repository where my app lives, or where the deployment manifest of my app lives, and is creating a file. Again, in the blog, we talked about standardizing on Kubernetes API as something that both developers and platform engineers use to talk to each other or to get things done. So this is exactly this kind of file that is created. But first, let's check if the PR is there, if the demo gods are with us. All right, we have a PR. So let's click PR and see what we have. So now I'm a platform engineer. Maybe I need to approve it for some reason. So we have a new PR submitted to apps deployment. It's adding a new storage account, and it has some metadata from port. I can check all those things. Great. What this PR do? It creates a file. Again, this file follows the Kubernetes resource model and Kubernetes API. We have a kind, we have an API version, so-called GVK, a group, and so on. You notice that here we have the fields provided by developer. So there is some magic behind the scenes in a GitHub action, which actually takes the data provided by developer and it substitutes those variables, substitutes values of those variables. Suffice to say, this is the file that is going to be created in the repository once we approve this PR. So what happens then? As a platform engineer, I set up all the infrastructure and the pieces necessary to take the desired state, which is expressed in the YAML, and actually make it happen somewhere on a Kubernetes cluster. For this, I am using Argo CD. You can see we have nothing yet, just a bootstrap application. But when we actually merge the PR, of course, this PR was reviewed. You have to forgive me for not reviewing it. I'm very confident that my developers know what they're doing. All right, so this has been merged, meaning that there's a file now somewhere in the folder that Argo CD observes. When we hit refresh, we do have some things popping up. Remember, this is completely hidden from developer. This is something that platform engineering team works with on a daily basis. They know all the context and they know what's happening. So those things are cross-plane specific. If you haven't heard about cross-plane, don't worry, I have a few videos about it, blogs and other content that I will share in the description. What we have is we have resource group, that is an Azure resource group. We have a few objects which are actually Kubernetes resources. And we have another Azure resources like account, container, and something called usage. All those things are necessary glue, and all the APIs expressed in the same form that we've seen earlier in YAML that instruct Crossplane in this case to go and compose all the resources based off of the small YAML that we've seen earlier. So since this is now done, me as a developer, I want to know when my app is ready. I mean, all this tech is cool, but I don't really care. I want to know, hey, my app is there. I want to use it and I want to test it. So in order to do this, we can use Slack. You can see I've tried it earlier, and very simple integration with Slack that my platform team was so kind to put for me, so I don't have to ask anybody whether my app is up. I can go drink coffee and come back later. So here on the local host, we have a Kubernetes demo. I realized that this color is a little bit too much. Anyway, Azure Storage Blob Reader connected but found no document. Okay, so it works. It's there. It's up and running somewhere in Kubernetes. To be more specific, on my local kind cluster. The developer doesn't need to know it. So this part from both sides was pretty clean. We have used Kubernetes resource model, we've submitted some files, Crossplane did some magic, and at the end of the day, the developer clicked the button and there pops up the whole app and accompanying infrastructure. So let's check the infrastructure. You can see here in the platform demo, the resource group in Azure, we have the platform demo storage, and inside of this storage, there's a container called, I believe, sample blob or something like that. And this sample blob is empty. So there's nothing inside. So as a developer, this is actually what I want to do. I created the application, I created the accompanying infrastructure in Azure without explicitly doing so. And I want to be able to submit a file and see whether my app works. So for this to work, I can switch to being a developer again. I am in my apps deployment folder, or repository rather, and here I have blob content in an examples. And this blob content, you will notice, let me make it a little bigger, it has a kind blob and it references the storage account and the container by name. In this case, it could be referenced differently, meaning that we are using the same context here, and we are going to provide another YAML so that the file can be created and I can see whether my really complicated app can work with emojis and can work with new lines. Let's give it a try. I have an alias for kubectl apply, and we are up and running. So now let me go back to my app, fingers crossed. All right, we got hello world. It actually displays emojis quite nicely, and we have a new line here as well. That also means that it did create the file inside of my Azure container. All right, this is great. So far, everybody's happy. We have created Azure infrastructure. The whole process was fully shifted left. Developer was able to do it. But there was another link provided by platform here. This link is actually for observability. So if as a developer, I might be interested, how does my app perform? Maybe I have to tweak resources utilization or something else. So we also can provide a dedicated dashboard for developers. So all this experience comes from the platform team, and that talks to developers and says, what do you need? And I can provide it automatically. So as a developer, I'm happy. This worked well. My app works perfectly, and we're gonna have a great sales of this application. Everybody's happy. Amazing. But now we don't want this app anymore. We want to get rid of the app. We want to get rid of the infrastructure. We don't want to pay the bills if we don't have to. Similar process, but in reverse. As a developer, I come back to my portal, which is my window, the whole world, and then I'm triggering another action. Delete. In order for this action to work, I have to choose an appropriate repository, and then I have to go back to my apps deployment repository. Remember, this is the one which contains the deployment manifests, and I have to provide a name of the file that I want to remove. This is the file that was submitted. So let us copy the file name, go back to port, enter value, and delete. So you can definitely imagine what's happening behind the scenes now. We have GitHub Actions being created, and instead of the file being created, it's now being deleted. So one more time, becoming a platform engineer, we are looking at pull requests and we have removing Azure storage. Awesome. I'm going to merge it, confirm, delete the branch, and let's check Argo. If we refresh, we shouldn't see anything because the resources were deleted. So let's give it a try. All right, Argo shows that we are good to go. Let's check our cluster. And remember, all the things I showed you are running on my demo local kind cluster. So I have an alias for watching cross-plane resources. As you can see here, we have still a resource group left. We have the namespace and few other resources that are currently being cleaned up. So I instructed Crossplane to delete all the resources if the file is being removed. Remember, we are following Kubernetes resource model and API principle. So kubectl delete file means remove the resources. I could have set it up differently. I could have actually set resources that they are not removed, but those are crossplane specific things that I don't want to talk about today. All right, one thing I want to show you a little sneak peek in how it's done behind the scenes. If you are interested in it, I am going to record one more video talking at length about this setup, but real quick, you can see it's another YAML file, in this case, kind composition, that is a crossplane specific YAML file that references, actually says what should happen when this small YAML that we submitted at the beginning is created within the cluster. So it creates various resources. You can see those name, base, and kind. It creates a resource group, it creates an account. So all those CRDs, custom resource definitions that Crossplane uses under the hood, actually correspond to external resources. And we have our Kubernetes cluster responsible now with Crossplane on top for managing the lifecycle of external resources. We are using it as a universal control plane, similarly like cloud providers do, to manage external resources. So this is the main thing that we want to focus here. And of course, the YAML is YAML, right? Writing it is not fun. You can automate it in various ways. But at the end of the day, this is something that stays with the platform team. Developers don't have to see it, and everything is 100% automated. All right, so all our resources are removed. Developers are happy. Platform teams are happy. And this is an example of how platform can be created. I encourage you to go back to the blog and read further after the video. There's a few paragraphs in the blog of how we've done this, what are the underlying principles, tools, and a little diagram guiding us again through the whole process. All right, I hope you enjoyed it, and see you in the next one.